Hi, this is Maggie from Design Code Debug Repeat. Welcome to the channel and to our 7th video in the Introductory R series. In the previous video, this video, and the next one, we're covering some programming features of R. In the last video, we talked about if statements. In this video, we're going to learn how to write functions. I have here our script from the last video, which I've renamed to functions.r. This script works with our AI data, a table of investments in different categories of AI research for the years 2017 through 2021. In the last video, we talked about reading in separate tables for the purpose of combining them into one large table. When data is collected over many years, the tables sometimes have different columns. We need them to have the same columns in order to combine them. We imagined a scenario in which some tables had a code column and some didn't. As we read each table in, we checked if the table had a code column and removed it if it was there. That code is here at the bottom of the script. If code in call names AI 2020, I is assigned the value of which call names AI 2020 equals code, AI 2020 is assigned the value of AI 2020 minus I. And then the same code repeated, but for the AI 2021 table. So the code is a little repetitive because we're repeating it for each table. We showed how to do this for 2 tables, but what if there were 5, 10, or hundreds of tables? It is not efficient to repeat this procedure for each table, and it also increases the opportunity to make an error. Each time we write code, there is a chance we will accidentally introduce an error. What if I copy the code for the AI 2021 table and paste it for a 2019 table? But forget to change the name of the table in one place, such as here, where I remove the column I. The code might cause an error, or it might execute without error, but it could remove another column from the AI 2021 table, depending on what columns are present and in what order. You may have guessed by the title of this video that functions are a way we can solve this problem. When there is code that is repeated, maybe with slight differences that can be parameterized, we'll talk about what that means in a moment, then we might have a good candidate for a function. A function is a named block of code that we can execute whenever we want to by using the name. We define a function, meaning we associate the name with the block of code, and once that is complete, we can use the name to call or invoke it wherever we need that code to execute. So we write it only once. Let's move this code into a function to illustrate. We're going to define the function at the top of the script under the comment. We need to define the function before we use it, so we'll define it at the top of the script, and then we'll be able to use it anywhere in the script. So let's call the function removeColumn. So I will type removeColumn is assigned the value function. Function is a keyword, and it is all lowercase, open paren, close paren, then open curly brace, enter, close curly brace. Inside the curly braces, we put the function code. That is the code that will execute every time we use the function name, which is removeColumn. I have 2 examples of this code below, both slightly different because each works on a different table. I'll copy the first block and paste it into my function. So now my function reads, between the curly braces, if code in call names AI 2020, I is assigned the value which call names AI 2020 equals code, AI 2020 is assigned the value AI 2020 minus I. Now we know that will work to remove the code column from AI 2020 if it's there. But what about the AI 2021 table? What about the AI 2019 table or the AI 2023 table if I can find more recent data? What I've written will work, but it's not very general. It doesn't help me reduce the amount of code in my script or make it less prone to copy-paste errors. That's where parameters come in. Parameters are a way to specialize how a function works for each situation in which you want to use it. We have called functions with parameters before. For example, when we call readCSV, we pass in the name of the file we want to read. readCSV would be much less useful if it always read from the same file. If we look at our two situations in which we're using this code, it's the name of the data frame that's different in the two blocks. So we can parameterize our function by passing in the name of the data frame when we call it, and write the code so it works with any data frame we pass in. Down where we're going to call this, we will replace the block of code that removes the code column with the name of our function, remove column, and then in parentheses after the name, AI 2020. After I read in AI 2021, I'll replace the code that removes the code column with remove column AI 2021. Now, that's not quite finished yet. We'll revisit this code in a moment. Right now, we need to rewrite our function to accept and use that parameter. So instead of working with AI 2020, we want the function to work with whatever data frame we pass in, whatever data frame we put inside the parentheses when we call the function by using the function name. In one case, so far, that's AI 2020, and in the other case, it's AI 2021, but in the future it could be AI 2023 or AI 2024. All we know is that we're going to receive a data frame that may or may not have a code column. We need to think of a name for that space where we can receive any data frame. Let's call it DF. So everywhere I have AI 2020 in this function code, I'm going to replace that with DF. So inside the curly braces, this code now reads, if code in call names df, I is assigned the value which call names df equals code, df is assigned the value df minus I. But what is df? Where does df get its value? We know that when we call this, we're going to put the name of a data frame in the parentheses. Here, where we're defining the function, we put df in parentheses. And whatever is in parentheses when this is called will be copied into the variable df. So the first time, AI 2020 will be copied to df, and the second time, AI 2021 will be copied to df. And in the future, maybe another data frame. Down below, where we've written remove column AI 2020, when this script executes, once this line is reached, execution will jump up to the function code, copying AI 2020 into df. And then after the function executes, execution returns to the call, and a few lines later we call remove column AI 2021, and execution again jumps up to the remove column function, but this time AI 2021 is copied into df. So that's how we send data, parameters, to a function so that it can be more general. We write it so it can work with any data frame. But there is an important missing piece. As I mentioned, when we write remove column AI 2020, the data frame AI 2020 is copied to the variable df. It is not the same data frame. So removing the column in df is going to have no effect on AI 2020. If we want to copy df back to AI 2020, we have to write the function and the call to do that. This is a good thing. It means that we can pass a data frame to a function, so the function can do something with the data, but it won't have any side effects or make any potentially harmful changes to our data frame back where we made the call. And back where we make the call, we can have the choice to take the altered data frame and save it. So we do that first by making sure the function's last line evaluates to what we want to send back. We want to send df back. So after the if statement closing curly brace, I'm going to write df. A function evaluates to its last line. If you've programmed before, this is equivalent to writing return df. If you haven't, just remember that if you want to send something from the function back to where it was called, and you usually will want to do that, then you need to put that thing last in the function. And where we're calling the function, we're going to assign that thing that's returned to our data frame variables by writing AI 2020 is assigned the value of remove column AI 2020, and AI 2021 is assigned the value of remove column AI 2021. This is similar, again, to how we call read CSV. We don't just call read CSV and pass in a file name. We call read CSV and pass in a file name, but assign what's returned to a variable name so we can actually work with the data that read CSV read in. Now, two more things. First, let's make this function even more general. Let's write it so that it can remove any column from a data frame. Right now, it's only removing the code column. Can you guess how to do that? Remember that we wrote it to remove the column from any data frame. Now we want to write it to remove any column from any data frame. If you guessed that we'll parameterize it with another parameter, you're correct. Now I can put this new parameter before or after the other parameter. I just have to be careful to match the order of parameters in the definition to the order of parameters in my call. So I'll add a parameter to my function definition and I'll call it call name. So after df, comma, and then call name. And then inside my function, I'll replace quote code quote with call name. Now, down where I'm calling the function, now that it takes two parameters, I'll have to supply two parameters to each invocation. So AI 2020 is assigned the value of remove column AI 2020, comma, code, close paren. And we must make sure we're writing code in quotes because it's the name of the column, which is character data. And the same below, AI 2021 is assigned the value of remove column AI 2021, comma, code. Let's put a call to view for each data frame after we remove the column and run the script. And if we look at the views, we can see the code column has been removed from both data frames. Now, one more thing, and that's documentation or comments. I'm going to write a comment for our function that uses the roxygen2 format. This format, if you're writing a package, can be used to automatically generate documentation for the package. If you're familiar with JavaDoc in Java or docstrings in Python, you know that there are documentation standards that allow external documentation to be generated. They are also the standards that most programmers will be using, so they'll make code more readable. So we should practice these documentation standards so we know them, and to make our code readable. We are not going to create a package with external documentation today, so we're just going to use this format for our internal documentation. Now, if you want to ultimately use roxygen2, then you should in the console type install.packages roxygen2 to install the package. I have already done that. Then what I'm going to do is click inside my function and go to the code menu and choose insert roxygen skeleton. And notice that it puts some comments that begin with £, single quote, above my function header, the first line of my function. The first comment says title. I'm going to replace that with remove a column from a data frame. And then there is a blank comment line, and then two lines with the @param tag, one for each of our parameters, df and call name. After each one, I'll write a description. After df, I'll write the data frame that might have the column to be removed. After call name, I'll write the name of the column to be removed. And then there's another space and an @return tag, and I'll write the data frame with the column removed. So I'm going to delete @export and @examples. But you can provide examples here, which can make the function even easier to use. We've looked at examples in the documentation for R functions before, and it's very helpful. So that is an introduction to writing functions in R. The code, as always, will be uploaded to my GitHub repository with a link in the description. I hope you found this helpful. I suggest you practice with this by writing some functions of your own. For example, you could take another part of this script, like the part that checks if a value is over 1 billion, and write a function to do that. It should take a parameter, which is the value to check, and it should return true or false. Have fun with it.